Welcome to Python Tutorial, Lesson 21. Today we learn encapsulation in Python. We protect data with properties and access control. Encapsulation means bundling data and methods that modify it together. Python uses naming conventions to signal access levels. Double underscores trigger name mangling for true privacy. Let us create encapsulation _basics.py. Dog has public attributes. Anyone can read or change name and breed. Public means no restrictions. We set name to max directly. A single underscore marks salary as protected by convention. Protected means other developers should not access it directly. But Python does not enforce it. Direct access still works. Double underscore makes balance truly private with name mangling. Python renames it to underscore bank account underscore balance internally. Accessing the mangled name works but is not recommended. The normal name raises an attribute error, enforcing privacy. Let us review the code with that. Now let us run the code. Public attributes change freely. Max replaces Buddy. The mangled name reveals the internal renaming Python applies. And the direct access correctly raises an error. Properties let you add logic to attribute access. The app property decorator creates a getter method. Setters validate data before allowing changes. Let us create property _decorators.py. Temperature stores Celsius as a protected attribute. The app property decorator exposes Celsius as a clean attribute. The setter rejects values below absolute zero with validation. Fahrenheit is a computed property that converts on the fly. We create 25 degrees and read both Celsius and Fahrenheit. -300 triggers the value error. Circle has a settable radius, but area is read-only. The radius setter rejects 0 or negative values. Area is read-only since it has no setter. We test radius changes and try setting area directly. Let us review the code with BAT. Now let us run the code. Temperature converts correctly between Celsius and Fahrenheit. The setter caught -300 as below absolute zero. Assigning to area raises an attribute error since it is read-only. Let us build a bank account system as a mini project. Private balance prevents direct manipulation of funds. Savings account adds a minimum balance constraint. Let us create bank_account.py. Bank account has a class-level interest rate of 2%. Owner is protected and balance is private with _. Properties expose owner and balance as read-only attributes. Deposit validates the amount and adds to the private balance. Withdraw checks for sufficient funds before subtracting. Interest is a computed property from balance times the rate. Savings account inherits bank account with a higher 5% rate. The minimum balance constraint prevents overdrawing. Withdraw overrides the parent to check the minimum first. We create a checking account with 1,000 and savings with 5,000. Method chaining lets us deposit 500, then 200 in one line. Savings deposits 1,000, then withdraws 2,000. Withdrawing 10,000 from checking triggers insufficient funds. Savings blocks the withdrawal to protect the 500 minimum. Interest comparison shows the different rates in action. Let us review the code with BAT. Now let us run the bank account system. Alice starts with 1,000 checking and 5,000 savings. After transactions, checking has $1,550 and savings $4,000. Both validation errors fire correctly, protecting the accounts. Let us recap encapsulation in Python. Underscore signals protected, double underscore is private. Properties create clean getters and setters. Validation in setters protects data integrity. Thanks for watching. Subscribe for more Python tutorials. In the next lesson, we cover polymorphism and duck typing.